Let's start looking at clutches. A clutch is a machine member used to connect the driving shaft to the driven shaft so that the driven shaft can be started or brought to rest when required without stopping the driving shaft. Clutch is used in automobiles, so you will see that when changing gears or stopping the vehicle, it is important that the driven shaft be stopped. However, the engine is kept running. It is therefore necessary to disengage the driven shaft. The engagement and disengagement of the shaft is achieved by a clutch. So in a nutshell, clutch allows you to engage and disengage the driven shaft from the driving shaft. So in terms of cars, the driving shaft comes from the engine side and the driven shaft goes towards the which provides the power to the wheels. So mainly there are two types of clutches. These are positive clutches and friction clutches. For our course, we'll be looking at friction clutches, and in friction clutches we've got three distinct categories. One is disc or plate clutches, the other one is cone clutches, and finally centrifugal clutches. So we will be looking at all of these in this particular chapter. So what happens is, before we move on as to how a clutch functions, it is important that we understand the basic elements of a clutch. So what happens is, the power is coming from the engine side. So on the engine side of the shaft, which is the driving shaft, we have a flywheel, and then what happens is the clutch is normally in contact with the flywheel. So that's how the power is transmitted from the driving shaft to the driven shaft. But when we want to change the gear, the driven shaft has to be disengaged. So what generally happens is, the clutch in that instance loses contact from the flywheel, and as a result of that, the driven shaft does not rotate anymore. So you've got the clutch plate over here, and then what we have is we have the pressure plate. So the function of the pressure plate is to provide some form of support onto the clutch plate, and the clutch plate also has some anti-shock springs. The purpose of this is to maintain the rigidity of the clutch plate itself. It does not vibrate and it maintains its surface contact with the flywheel. Then what we have is we have the diaphragm spring. So this is the spring that is generally responsible for engaging and disengaging of the clutch. So here in this animation, what you see is, you can see how a clutch disengages and engages. So what we have here is we have a lever fork. As soon as you press onto this lever fork through the clutch pedal, what generally happens is the lever fork moves in. The lever fork moves in and it presses onto the diaphragm spring. The diaphragm spring at this end causes the pressure plate to move outwards. As this happens, you'll see that the clutch disengages from the flywheel. Once you remove your foot from the clutch pedal, the lever fork moves outwards, the spring returns to its original position, which causes the clutch plate to engage or hold on to the flywheel, and hence power transmission takes place. A friction clutch uses the force of friction to start the driven shaft from rest and slowly brings it up to the required speed, and transmits power with little slippage between the friction surfaces. In automobiles, friction clutch is used to connect the engine to the drive shaft. Now what happens is, in order for us to understand what constitutes a good clutch material, we need to look at certain factors. So some of the points that we are mentioning here is similar to the characteristics of the material that we want when we're looking at brake pads. So the material used for lining of friction surfaces for a clutch should have the following characteristics. It should have a high and uniform coefficient of friction. So you want the material to have high coefficient of friction because it will be able to hold on to the flywheel effectively. It should not be affected by moisture and oil. So what this does is, if the material does get affected, what it will do is it will lose its effective grip onto the flywheel, and as a result of that, there will be some slippage in transmission. So we want to avoid this. It should have the ability to withstand high temperatures. Again, as the engine rotates, depending on the speed, the driving shaft also rotates at a particular speed. So they are high energy transfer formation taking place. So we want the material to be able to withstand these high temperatures, because the clutch is always in contact with the flywheel, so there is issue of high temperatures. So the material should be able to withstand this high temperature, should have high heat conductivity, so it should be able to remove heat really quickly, and it should have high resistance to wear. What it means is that just because the material is in contact with the flywheel, or the clutch is in contact with the flywheel, there's constant contact and there's constant wear. So we want a material that has a very low wear rate. So whenever we design a clutch, we need to look at several factors. So the number one factor that is based on the selection of suitable material forming the contact surfaces, so which we covered in the previous slide. The material should be stiff enough to ensure uniform pressure distribution. The contact surface of the clutch develops frictional force large enough to pick up and hold the load. So you don't want a material that is not able to hold onto the load. The moving parts of the clutch should have low weight in order to minimize the inertial load. You don't want a cumbersome clutch system, because there will be losses in transmission due to its own weight. So inertial losses, we want to minimize inertial losses. The clutch should not require any external force to maintain contact to the friction surface. So what this means is naturally the clutch should be in contact with the flywheel in order for transmission to take place. You don't want any external form of force to maintain this contact. So in a automobile clutch system, this could be done with use of compression springs. The clutch should have provision for conducting repairs, just in case you need to do some maintenance. The clutch should dissipate heat rapidly, because we understand that if heat is not removed, the material from which the clutch is made, it is going to lose its mechanical properties. And then finally, the projecting parts of the clutch should be covered by a guard. So this is very important. Now these are few examples of disc clutches. So this basically shows the entire arrangement. You've got the flywheel, you've got the clutch plate, you've got the pressure plate, you've got the compression springs that I was talking about, and this is the cover. This is your lever fork, which moves in and out depending on when you press on your clutch pedal. And this shows the clutch plate itself. These springs provide rigidity to this clutch plate, at the same time maintains its shape. And you can see the same thing over here, showing the entire clutch setup. So now let's look at disc clutch analysis. The analysis of disc clutch is done for two different conditions. One is when we have uniform wear, which is when we assume that the disc clutch is a rigid disc, and the other one is for uniform pressure, when we assume that the clutch plate is flexible in nature. So for uniform wear, after initial wear has taken place and the disc has worn down to a point where uniform wear is established, then these equations can be used. So you can see that these equations are similar to the equations that we use for analysis of disc brakes. So clutch and brake, the analysis is similar. So again, when you look at this diagram, capital D is the outer diameter of the disc clutch, small d is the inner diameter of the disc clutch, Pmax is the maximum pressure, sometimes called the lining pressure, F is the coefficient of friction, Fa is the actuating force. So these equations can only be used when we have a case which deals with uniform wear. Now what happens is, we need to be mindful that actuating force is independent of the number of friction surfaces that we have, and for torque is dependent on the number of friction surfaces that we have. Please be mindful that these equations are true for a complete disc, which is 360 degrees. So what generally happens is, if you're just given a sliver or just a portion of the disc clutch, then what we need to do is, we need to multiply over here in equation 1 theta over 360. So theta would be the angle of the included angle of the clutch or the disc clutch that is given to you. Similarly, for equations 2 and 3, though it's not shown here, this is only true for one friction surface. So if you have two friction surfaces, then all of these is multiplied with 2. Now same thing over here, this can be multiplied by 2 as well. If you've got 3 friction surfaces, multiplied by 3 and so on. Now equation 4 is only used for a very special case, applies only for uniform wear. Minimum pressure occurs on the outer surface, which is your capital D. Maximum pressure occurs on the inner surface, small d. So the average pressure is basically the ratio of axial load to the surface contact area, and your average pressure is simply given by 4 times your actuating force divided by pi into capital D squared minus small d squared. For uniform pressure, these equations will be used. Again, keep in mind that your actuating force is independent of the number of friction surfaces, whereas your torque is dependent on the number of friction surfaces. Again, if you've got 2 surfaces, you will have 2 multiplied to all of these, and again here over here, again you will have 2 multiplied to rest of these equation. Now what we have is, this is just a general case, irrespective of whether you're given a uniform pressure or a uniform wear case. But what generally happens is, the question would specify sometimes some of the parameters would not be given to you. For instance, if outer and inner diameter are not provided, then you will use equations 8, 9 and 10 to solve the problem. So in general, total frictional torque acting on the friction surface or on the clutch is given by torque is equals to NF where again N is the number of friction surfaces, F is the coefficient of friction, and R is the mean radius of the friction surface. For uniform pressure, R is calculated using equation 9, and for uniform wear, R is calculated using equation 10. So these equations are used when you're given a problem which is generally maybe in a general form.